And so yeah, so our derivative rules continued. And like I said, I'm going to ask you to do this a lot of times this year, probably 100 times. So this is time number 2. Maybe I'll just keep track. Take a couple minutes to do this. We need to do a few things, and the order of them doesn't really matter. What is something that we could do? Oh, spoilers. What is something that we could do first? Jonathan.
Set the square root of x to x to the 1/2.
Okay, make this x to the 1/2. And how could we rewrite the other one?
X to the power of negative.
Okay. Yeah, okay. I would say this is not a necessary step, but is helpful when you're doing the power rule just to see the exponents of these things. This is one, the derivative of that I would recommend memorizing, but if you don't have it right now, that's okay. So what can we do next?
The derivative of that.
Yeah. So h prime of x, so notice how I'm labeling it. H prime of x equals, what's the derivative in any form?
1 over 2 root x minus 2 over x to the 3rd.
Okay, nice. Your derivative doesn't have to be written that way. It could be written, a couple other ways here, like 1/2 x to the negative 1/2, 2x to the negative 3rd power. I would recommend this one though, because it's the easiest to work with, because we do have to work with it, right? What do we need to do with that?
Plug in 1.
Yeah, we need to plug in 1. How would I write that notation-wise?
H prime of 1.
Yeah, exactly. H prime of 1. And what does H prime of 1 equal? Negative 3 over 2. Yep. So it's like 1/2 minus 2. Again, for me, that's hard to plug 1. Even plugging 1 in, it's hard to plug it into that right there, just because the negative power, the fraction power kind of messes with my head. So I like h prime of x looking like that, but it doesn't matter. So h prime of 1 is negative 3/2. What does negative 3/2 represent? The slope of the tangent line, right? So that's part of our answer. That's going to be our m right there. And what else could we fill out in this tangent line right now? Yeah, yeah. So we could put our x value there. And then how do we get our y value? Yeah, nice. Okay. So yeah, notice the notation. H prime of x equals, h prime of 1 equals, h of 1 equals, and then we have our tangent line. Actually, in calculus, it's frequently better to not box your answer, which is kind of crazy. But like on free response questions, it's better to just leave it like
Would
this.
there be any effect if you box your answer?
So it depends on what the question was asking. So if I was reading this quickly and I thought, oh, I'm just supposed to find the derivative, and I box this, I'm gonna
boxing your final answer.
yes. If I thought that it was asking me to find the derivative and I box this, I'm gonna get the question wrong, right? Because it's not what it's asking for. But if I had all this work on a free response question, and I thought I was supposed to find h prime of x, but maybe I was just in a rush and I just did a bunch of stuff. Since all of this stuff is correct and the right answer is there, I would get full credit for this, even if I thought I was supposed to be finding this. So that's kind of a thing with FRQs on calculus. If you're not exactly sure what you're supposed to be finding, and you do some stuff that, as long as it's correct and as long as it makes sense, you can't just like just write random numbers down. But if your work is clearly labeled and the right answer is there, you are going to get credit for it on a free response question. And so boxing your answer is often strategically a better choice to make, especially if you're not sure if you understand the question. Again, everything has to be true. If I say h prime of 1 equals 3, I'm going to lose points for that because that's not a true statement. So any false statement anywhere in your answer will lose your points, but if you have correct work and it's labeled correctly and the right answer is there, you're going to get credit for the right answer. So just something to keep in mind. And that'll be true for our FRQs as well. But this is the final answer. So I'm going to go ahead and box it so that we know what we're looking at. And like I said, we're probably going to do this 98 more times this year. We're going to also occasionally see questions like this. Write the equation of the normal line to h of x at x equals 1. Anyone know what a normal line is? I probably didn't hear this phrase till I was in AB as well. Okay, a normal line is a line that's perpendicular to the curve, to the tangent line. And it's at the same point. So if we ever see a question like this, it's the same process as finding a tangent line with one more step. So we found the tangent line. Turn to your neighbor. What's the one more step we need to do? Okay, so my normal line is y minus 2 equals 2/3 x minus 1. All we need to do is do the opposite reciprocal slope. And so to find a normal line, we do need to find the tangent line first. We get the slope, we get this slope from the derivative. The derivative will tell us that slope. Then we just flip the fraction over and make it negative. And I actually want to pull this up on Desmos and just show you guys because I think it helps just to visualize it. So y equals root x plus 1 over x squared. So there's my curve. And then our tangent line was y minus 2 equals negative 3 over 2 x minus 1. Boom. It's nice, right? Satisfying. And then our normal line would be, I'll just type it, y minus 2 equals 2/3. Nope, not like that. X minus 1. Ta-da. So there's my normal line. It's just perpendicular to the tangent line, so it's kind of like piercing that curve there. Who's in physics or has taken physics? You know, normal force. It's perpendicular to the surface or something like that. I'm bad at physics. I should be good at it. But yeah, it's the same. Yeah, that's that, right? That's normal force. Just on a graph or something like that. I should be a physics teacher, right? Cool. You'd think I'd be good at physics because I love geometry and calculus, but I was not when I took it in college. Anyways. Let's look at some other things. What do I have for us? Oh yeah, in the packet, page 4. So we're going to revisit our limit definition of a derivative. I think if I took physics again, I would be good at it. I did not have a good physics teacher in high school. And in college, I was just taking it because I had to. So I wasn't really trying to learn it. So natural segue here. Okay, so like I said, we are never going to have to take a derivative the long way ever again. But we are going to be, we are going to be given questions like this, where we do have to evaluate what this expression equals. Hold on a second. So as we look at that, we have to keep in mind the limit definition of a derivative. We just don't actually have to, you don't have to FOIL this out. You don't have to FOIL that 2 plus h to the 7th out. You don't have to do it. So what we want to remember is our limit definition of a derivative. So turn to your neighbor. How would we fill this out the h way? Ready, set, go. Okay, so it's a limit of what? Okay, nice. If we did this at a specific point, let's call it A, what would I change to A? Like if I wanted f prime of A equals, still the h way, A plus h minus f of A, yes. So remember, there is a version of the limit definition, the h way, that can tell you a specific derivative at a specific point. So when we are asked to evaluate this, what we need to ask ourselves is, what is f of x? What is f prime of x, using the power rule? What is f prime of A, whatever it's asking? So, as I'm looking at that, what function are we taking the derivative of? Can you see it in there? X to the 4th. Yeah, it's x to the 4th. At x equals what? Yeah, so it's, 3 plus h to the 4th. This is 3 to the 4th. Okay? What is the derivative of x to the 4th? Yeah. Okay? And so now what is f prime of A? We plug in 3 to that. What do we get? 108. Yep. Okay, so we don't need to do it the long way. We need to be able to identify what is f of x, what is A. I should have put that question in there. And then actually just take the derivative using the shortcut. That's how we're going to do this. So you guys do that for number 12. Okay, so in number 12 here, what is f of x? What's f of x? Root x. And A is 4. If we do the derivative of root x, it's 1 over 2 root x. Yeah, and remember, just memorize that. We plug in 4 for x, and we get 1/4. Okay, so that's how we're going to evaluate this. Could we multiply by the conjugate on the top and bottom? Yes, we could. We won't. You can't. You don't need to anymore. Now we're trying to recognize that that is the definition of the derivative. We know a faster way to take derivatives This is our transition into unit 2. We don't need to take a derivative the long way. Could you multiply this out and simplify and cancel out h? Yes, you could.
But it's going to take forever.
It's going to take forever. Maybe even 5 ever. So we don't need to do it. Recognize that it's a derivative. Take the derivative the short way. There's some more examples here in the packet that you guys can do. This one, we need to know the derivative of cosine, so there's some on the next page too. We'll skip over this for now, but those are good extra practice. Obviously, we wouldn't want to FOIL out 1 plus h to the 100th power. That would be crazy. Okay, the last thing we're going to do today is we're going to do some derivatives on the calculator. So you need a calculator, go ahead and take it out. If you don't have one, share with someone next to you.
You would see yourself here?
No. Younger me did not know that he wanted to be a teacher. That was something I figured out in college. That's another interesting story.
Wait, you can be a teacher even after having a criminal record?
Yes, you can.
Just in case. Right?
Yeah, just in case. Yeah. Okay. I don't recommend it though. You should. Okay, let's talk about this. The calculator can do 2 things if you have a TI-84. If you have a fancier one, it can actually do more stuff. But this is what we're able to do. We're able to graph a derivative, and we're able to evaluate a derivative at a given point. And both things are really, really useful. And questions where you have access to a calculator, you are expected to use the calculator and make it way faster. So we will learn how to take this by hand, but it's good. We're going to get some decimal answers. So we want to be really, really competent at the calculator so that we can focus on the hard stuff. So we're going to use this as our function here. So in the calculator, go ahead. Let's make sure we're in radian mode. And let's clear this out. Type in sine of EX. And let's see what our window looks like. I don't want my window to look like that. I'm just going to go -10 to 10, and I'm going to go -5 to 5 just to zoom in a little bit. You don't have to do that, but get my nice little wave going right there. So that is sine of EX. So like I said, we can do 2 things. We can evaluate the derivative, any slope of a tangent line at any point, and we can also graph the derivative function, f prime of x. So the way that we graph the derivative function is go back to y equals and go down to the second line there. And what you're going to do is this can be found in 2 places. So it's either under math and it's option 8 for n deriv right there, or it's under alpha window, alpha F2, n deriv right there. I like to press math 8. That's the fastest one for me. So, but it's, you know, tomato, tomato, whatever you want to do. So if I do math 8, boom. We need to fill some of these blanks out. We need to make this d dx because x is our variable. In the parentheses right there is what we're taking the derivative of, which is the function above us. So we could type out sine ex, or we can just go to our variable list and put y1 in there. So that's alpha f4. And then when we're trying to graph a derivative, we need x equals x. When we're evaluating a specific tangent line, that's going to be a number. And then we can graph our derivative. And I'm actually going to zoom in a little bit here. So something I want you guys to notice is, look at the blue graph. Every time it hits a maximum or a minimum, my tangent line would have a slope of what? 0. And so notice the red graph is going through the x-axis. It has a 0 every time we have a maximum. That's actually going to be a huge theme this year in calculus. But we can graph our derivative. We can analyze the graph. And something that can be helpful is if I just want to see the derivative graph and not the original, what I need to do is go over to that area right there. And, oh, sorry, not that. That's not what I want. I want, okay. I want to go over the equals sign and I want to press enter. And that's going to turn that graph off. So it's going to graph the bolded ones. If I press enter over it, I can turn the graph off so I'm not seeing a million graphs all at
How
once.
do you put E of X in?
You type E, then you type X. E is on the division sign and X is next to the alpha button. Okay. Now, we can also evaluate a derivative at a specific point. And so the only difference here is we just do this in the main menu. I still do math 8. It's still d dx. I'm still using y1 as my function. And the only difference now is if I want the derivative at x equals 2, I just type 2 right there. And it will tell me the slope of the tangent line at x equals 2. If I try to do x equals x here, I don't know what it's going to do. I think that's just where the cursor currently is. So only do the x equals x when you're graphing. Okay, so this is something that you want to be able to do really quickly. And you don't want to have to be remembering how to do this. It's just math 8, x equals 2 for some specific tangent line, or 3 or 4, whatever. X equals x to graph the derivative. Okay.